Hello students, hope you are doing well. Today we are here to discuss the colloidal dispersion. In this, we'll discuss about the optical properties of colloids. So this is another very important topic from the colloidal dispersion system of physical pharmaceutics 2. This is Suryam, Assistant Professor, Department of Pharmaceutics, Vishnu Institute of Pharmaceutical Education and Research, Narsapur. Today we'll discuss about the different contents like the characteristics of colloids, like particle size, particle shape, surface area, surface charge, optical properties like Tyndall effect, light microscopy, ultra microscopy, electron microscopy, and turbidity. Coming to the particle size, as we discussed in the previous video, the substance which contains 1 to 1000 nanometer of the particle size, then that substance is known as colloidal substance or colloidal system. Similarly here, coming to the particle size, it should be in between 1 to 1000 nanometer, and the color of dispersion phase influenced by the particle size. The large particle size, the shorter wavelength of light transmitted, the color approaches the violet of the spectrum. Example, the colloidal gas has red color at the size 650 nanometers to 750 nanometer. So to decide the color factor of the particular colloidal dispersion system, the size is very important. Coming to the second property, that is particle shape. Here we will be having different types of particle shapes, mainly depends on the method of preparation. Examples, spherical shaped will be in red color, disc shaped will be in blue color. Some of the different particle shapes will be there as follows. Sphere shape will be like this. Short rod shapes will be like this all the short rod type of colloids. Oblate shape, long rod shape, threaded shape similarly to spherical or sphere shapes, they will be like a thread, and this thread like structure will be divided into loosely coiled shape. The coiling of this thread will be very loose, it will be looks like this. Branched thread shape, so this will be having some branches like that. Globule shape, this globule shape it is like a droplets, they will be like this to look. Another property here, surface area. Colloids have a larger surface area because they have smaller in size. The size already we know that 1 to 1000 nanometer, and the surface areas depends on the size of colloidal particle. The larger surface area enhances the solubility of the drug particle. Another property, that is surface charge. The surface charge of colloid pauses in their surface area. So the surface charges will provide the stability when they have some charged surfaces on the dispersed phase or dispersion medium due to repulsion. Surface charge also may leads to unstable when they have opposite charges due to attraction. So here in this statement, surface charge provides the stability when they have same charge surfaces due to repulsion. As we know, when we are dealing with the same charge particles, then the particles will repulse each other. That means they will move away from each other. So when the particles are moving away to each other, they will be freely dispersed. This particle will be freely dispersed in a particular substance. This may leads to the stability of the particular colloidal substance. Whereas coming to this, when the surface charges also may lead to unstable. Yes, when they have opposite charges. That means if you have positive and negative charges, what will happen in between these two particles? Attraction forces will be there. Because of the attraction forces, the particle size will be increases, and that may leads to increasing in the density. When the density is increases, the all particles will settles down like this, and this is known as precipitation or coagulation or sedimentation. So these properties may lead the particular colloidal substances to be unstable. The examples are acacia, tragacanth. These will be having positive charged, and the gelatin will be having negative charge. And here we need to discuss about the optical properties, also a very important topic of this characteristics of colloids. And this optical property helps in to get the information regarding the shape. Yes, already we discussed the size, also we discussed, and the structure of colloidal particles. These optical properties can be studied in detail by following different methods. That methods are Tyndall effect, light microscopy, ultra microscopy, electron microscopy, and turbidity. Let us discuss about all these one by one. Tyndall effect. This Tyndall effect was proposed by John Tyndall in the year 1860. This also known as Tyndall scattering. The phenomena of a scattering of a beam of light by a colloidal particles when passed through a colloidal solution is called as Tyndall effect. That means we need to arrange a source of light, and that source of light has to be passed through a colloidal solution, and that colloidal solution will be receives the light which is passing through them, and they make the light to scatter in different direction. This entire effect or this phenomenon is considered to be Tyndall's effect. When a light is passed through a colloidal solution, it observed that the colloidal particles do not permit the light to pass through it completely. Do not permit to pass through completely, because we know that the size of the particle of colloidal is 1 to 1000 nanometer. As per this colloidal or this Tyndall effect, all the colloidal particle will not allow the light to pass through them, because some of the particles will be having very larger in size, some of the particles will be having very smaller in the size. This can be viewed against a dark background only. This is very important point to be note, that this entire Tyndall effect is observed under dark background only. The visible light is 400 to 700 nanometer wavelength at particle size 40 to 900 nanometers, and these will be visible in blue color. And we'll discuss how the Tyndall effect will be will done. Initially, we need to take a colloidal solution, and now we need to arrange beam of light, which is also known as a source of light, and then the light will passes through the colloidal particles, and then the particles receive the light and the light will scattered. This is the process of Tyndall effect. So to understand in detail, here we will be having light source. So this is the light source, and now we are trying to pass the light rays through this colloidal substance. This is a colloidal solution. When we passes this light, some of the particles will receive the light, that means they will make pass through them, and some of the particles will not receive the light, they will be scatter the light. So the scattering will be takes place, and that scattering phenomenon is known as Tyndall's effect. And we know that this Tyndall's experiment will be observed under dark background only. If you are passing a light source through a colloidal solution and you are not maintaining black background, then we cannot observe the scattering of light. Whether this light is scattered or not will not be observed unless and until you are doing this experiment in the dark background only. And here the Tyndall cone, the luminous or path that results from the visible scattering alone, the path of light beam is called as Tyndall cone or Tyndall beam. So see, in this diagram we can find a cone like structure here, a cone like structure. This portion is known as Tyndall's cone. So this is indicates the path of light from the beam, also known as light source. This portion is known as Tyndall's cone. Example, a beam of light is directed at the glass of milk and the light is scattered. So this experiment we can do at our home also. If you take a glass of milk and you just put opposite to the light source, and that background should be dark, or else you can do this experiment at in a dark room also. So when the light is passed through the milk particles will not make the light to get scattered in different direction. This is considered as Tyndall's effect. Second property, now we'll discuss about the microscopy. So this microscopy works based on the principle the lens on receiving the light rays focuses the rays at the specific particle only. This is known as the focal point. When the light source is received, the light, and that light will be specifically pointed at a particular particle. That is the principle involving in light microscopy. And the range of the particle, when we have less than 1 nanometer, then only we can visible the particles by using this light microscopy technique. So here we can understand in detail about the light microscopy. So this will be the source of light. From here we can apply the light, and this light directly passes through condenser lens. This condenser lens will reflect the light towards specimen. Here we will be having the sample, the particle whose size want to be known, that will be placed on the specimen, and from this specimen the light will passes through the objective lens. Here we can see the object by the help of light. Object means we can see the sample here, and from this objective lens, this light will send to the ocular lens. Here we can see this ocular lens. By help of this ocular lens, we can see the particle shape with our eyes. This will be the procedure involving in the light microscopy. Now we'll discuss about ultra microscopy, also known as dark field microscope, and the visibility range of the particle is 10 to 100 nanometers only. So here in this ultra microscopy also we'll having a light source here, and this light source will be sent to the diachronic mirror. So this diachronic mirror will reflect the light towards the object, or also known as sample, and this sample will be placed on the surface of specimen. And this, when this specimen is received the light, the object will be visible. From this specimen, this light again reflects towards the emission filter. So this emission filter will eliminates the unwanted rays or light rays. So that what happened, the picture which is observed on the surface of specimen will be detect by the help of the detector, and this detector will be connected to the imaging extraction. This deflector will be connected to the convert as the image. So here we can observe the particle size and particle shape. This is the procedure involving in ultra microscopy. Now we'll discuss about electron microscopy. The electron microscope can resolve features that are more than 1 million times smaller, and they can give a photograph of the particle. So by the help of this electron microscope, of course we are not only visible the particle, but it can provide us the photograph of the particular particle which you are observing under this electron microscopy. So here it will gives 1 million times more than the particle's actual size. From here the electrons will be passes, and these will be acts as a light source. This will passes to the second intermediate lens, and from the second intermediate lens, first intermediate lens, and this will be passes to the objective aperture. And here we need to place the sample, and then this sample will be placed here, and from here this will be sent to the condenser aperture, and from this condenser aperture it will goes to secondary condenser aperture. From the secondary condenser aperture it will goes for first condenser lens. From here we can visible the structure of the particle or the sample. Now we'll discuss about the turbidity. So turbidity is a cloudiness or haziness of a fluid caused by large number of individual particles that are generally invisible with our naked eye. This method is used to estimate the concentration of dispersion phase and molecular weight of colloidal solution. This can be measured by using spectrophotometer. And the reasons, because of the larger size of both the dispersion phase and dispersion medium. Because of increasing in the size of this dispersion phase and dispersion medium, we'll be finding the turbidity. And this spectrophotometer is used to determine the amount or percentage of turbidity which is present in the colloidal solution. And this spectrophotometer is basically based on the principle that turbidity depends on relative intensity and transmitted light. Both are directly proportional to each other. So the relative intensity of light and the transmitted light, both are directly proportional to each other. That means the passing light is directly proportional to receiving light by the particle. Based on this principle, this spectrophotometer is going to work. Here we have a small formula to measure the turbidity by using spectrophotometer, that is L divided by L naught is equals to e power T L. By using this formula we can calculate the turbidity percentage by help of the spectrophotometer, that is I divided by I naught is equals to e power T into L. So where I naught indicates the intensity index of light, I indicates intensity of transmitted light, L indicates the length of the sample, T indicates the turbidity. This is spectrophotometer's mechanism actually. So light, that is the light source, will be passes through the sample. If the sample's particle size is more, then they will be scattered like this. If the sample's particle size is less, then this will be receives the light and it will be detect in the detector. This will be the major mechanism of a spectrophotometer. The turbidity of lyophobic colloids, in case of more dispersion phase, more light scattered and transmitted lights will be very less intensity. In case of lyophilic colloids, in this case, low size of dispersion medium, low light scattered, that means low turbidity. Examples: proteins and gums. So here you can see in this diagram, this will be have high turbidity, and here we can visible the clear solution. This is a clear solution, we can say. That means turbidity will be very less. Why the turbidity is very less? Because the particle size is very less. So when the particle size is less, then they will be passes the light through them, and so that we can clearly visible this solution. Whereas coming to this second solution, here we cannot visible the clear picture, because size will be more. When size is more, then they will not allow the light to pass through them, and this may leads to scatter of light. Because of this scattering of light, the solution, the entire solution will looks like the turbid solution. Thank you, dear students, hope you are understood.
Like, share and subscribe. Hit the bell icon for more updates.